Hello everyone. Today I'm going to present exploring statistical concepts, sample mean standard deviation, confidence interval assumptions, and hypothesis testing for standard deviation claims. I'm excited to delve into the fascinating world of statistical analysis with you. Throughout the presentation, we will be exploring some foundational concepts that are crucial for understanding and interpreting data effectively. We will start by discussing how we calculated the standard deviation of sample means, giving us insight into the variability of our sample estimate around the population mean. Then we all move on explore the key assumption necessary for constructing confidence intervals, ensuring that our estimates are reliable of the occurrence. Finally, we will delve into the hypothesis testing, where we will use statistical methods and you evaluate claims about population standard deviation. By the end of the presentation, we will have solid understanding of these essential statistical tools and how they can be applied in the real world scenarios. Let's get started. Sample means standard deviation. Let's dive into the calculating the standard deviation of sample means. Imagine we have received a random sample size of 345 from the population with a mean of 150 and standard deviation of 180. To find the standard deviation of the sample mean, we applied the formula deviating the population standard deviation by square root of sample size. In this case, the standard deviation of the sample mean would be approximate 9.69. But what does this standard deviation signify? Essentially, it tells us how much the sample means expected to vary around the population mean. So in our scenario, a standard deviation of 9.69 indicates that on average, the sample mean are likely to deviate from the population mean approximately 9.69 units. This measure helps us guide and precious and reliability of our sample estimate. Confidence interval assumptions. Now let's discuss the critical assumptions we make when constructing confidence intervals, particularly of at 95% confidence level. First and foremost, we assumes that our sample is obtained throughout random sampling, ensuring that it is respective of the population. Next, we rely on assumption of independence, meaning that each observation of our sample is unrelated to the others. The ensure that our sample data is free from any bias. Lastly, we assume either a normal population distribution of the sufficiently large sample size for the central limit theorem to apply. These assumptions are critical as they guarantee the accuracy of the reliability of the confidence interval estimates. They provide a framework for interrupt that uncertainty associated with our sample estimate and help us make valid inference about the population parameters. Hypothesis testing. Let's put hypothesis testing into action. Suppose we are observing the hours worked by employees in workplace, and after analysis a sample of 32 workers, we find that the sample means is 42.1 hours per week with a standard deviation of 10.4 hours. Now we want to test the claim that the standard deviation in at least 13 hours. We set up our hypothesis. The null hypothesis HO state that the standard deviation equals 13 hours, while the alternative hypothesis HS suggested that it's less than 13 hours. Using a significant level of 0.05, we calculate a test statistic and compare it to the critical value or find the p-value. Based on this, we decided whether to accept or reject the null hypothesis. In this case, the calculate test statistics suggested that the standard deviation in indeed less than 13 hours. Leading us or reject the null hypothesis is favor of the alternative. This means there is significant evidence to support the claim that standard deviation is less than 13 hours. Hypothesis testing allows us to make data-driven decisions and draw conclusions about population parameters based on sample data. Conclusion. As we wrap up, we have covered a lot of ground and exploring essential statistics concept, from understanding how to compute the standard deviation of sample mean to discussing the critical assumption required for constructing confidence intervals, and finally we applying hypothesis testing to evaluate claims about popular standard deviation. These tools are invaluable for anyone working with data, providing with us means to draw reliable conclusion and make informed decision. I hope you have found the journey through statistical analysis insightful and informative. Thank you for journeying with me. Thanks a lot.